Welcome to Brain Vision.
In this problem, we want to find the force that the bicep muscle, shown in the figure, exerts on the forearm when you lift a 16 kilogram barbell with your hand. Also determine the force that the bone in the upper arm, the humerus, exerts on the bone in the forearm at the elbow joint. The mass of the forearm is about 5 kilograms, and its center of mass is 16 centimeters from the elbow joint. Ignore the tricep muscle. So here is a free body diagram of our system, and we have the mass of the forearm acting at a distance from this pivot point here, where this bone attaches to the humerus. That's 5G is the load. Out here at the end of the arm, we have 16G is the load. Here we have the force from the bicep, and it acts at distance d3 from the pivot point. And then at the pivot point, we have actually two loads, but it's pretty clear that this one here is going to be 0 since there's no other loads in the x direction. So we just have this load here that's basically keeping this bone attached to the rest of the arm. So what we want to do first off is we can take moments about this point so that this load drops out, and we wind up with again, I'm going to take clockwise positive. So we have 16G times this total length, d1 plus d2, plus 5G times this length, d1, and then minus F1 times d3, and that all has to be 0. And we know everything in there, so we can figure out that F1 must be 1,254 newtons. Now, if we want to figure out what this load is, well, we also know that this thing has to be in static equilibrium in the vertical direction, as well as rotationally. So we can sum the forces in the y direction, and that gives us F2 plus F1 minus 5G minus 16G, or minus 21G. And so we can solve for F2, and we can use this value in here, and this comes out to be minus 1,048 newtons, which means that the load is actually acting down on this on the lower bone, and then up. The upper arm is pulling back up on it. So that's the load in the joint.